analyst founder at Recon Analytics. We provide research, consulting, insight services to predominantly the telecommunications industry, but various other industries as well. Thank you very much for having me. I'm going to provide you an overview of what is changing in the world of telecommunications, and it's a lot. We're at one of those disruptive moments in time where everything changes, thank God, and everything changes at the same time, but not at the same with the same speed and the alike. So one of the things, and I'll talk about 5G, 6G, LEOs. I'll talk a little bit about how customers view all of this. And by the way, if you have questions, please ask. I don't want to pontificate here. This should be an interactive conversation guided with some of the slides that I have. And maybe we can go to the first slide, please. Oh, I need to do that myself? Okay, good. All right. I can do it myself. So one of the big things that we're seeing right now, we're seeing this both on the fixed side and the wireless side, but here I'll use it as an illustration on the wireless side, is the evolution from a hardware-centric world to a disaggregated world where everything gets virtualized. Basically, we're moving from smart toaster ovens to computers, where suddenly things are running on general purpose equipment. So traditionally, the world that we know in the wireless world, you have an antenna site, you have a base station underneath it that has both software and hardware that translates all of this, and it moves it back to switches, to the core, to the packet core, and then connects out to another network, to the same network, to another site. And so it's pretty straightforward and we've built it like this for 40 years, right? That's the bread and butter that we're seeing. The disadvantages here is these base stations are closed boxes, and the innovation has to go hand in hand. So only the guy who builds the boxes, the Nokias, the Ericssons, the Samsungs, they have to build this together. And it's a closed box, and so the technology moves at the slowest pace of all of them. And there are only a limited number of people that can spend billions of dollars in this, right? There were, 30, 40 years ago, there were about 10 providers of this. Now, for all intents and purposes, there's Ericsson, Nokia, Samsung, Huawei, and ZTE. And Huawei and ZTE are in China and predominantly in Africa and Asia. And so, but the world is not standing still. So what happened next is they are creating, the base stations are becoming more powerful and are now controlling multiple sites. One of the reasons why you have a dropped call is when you're moving from one cell to the next and the handover doesn't work. Because in the world of 5G, it is break before make. So when there's a transition between cell sites, right, in 5G and in 4G, you have to cut the connection before the next connection starts. That gives you a lot of drop. That gives you a good chance of a dropped call, because it's like you're hanging off a mountain cliff, and you're going from one guy to the other, and right, you don't want to let go before you have the other hand, but in 4G, 5G, that's what happens. You have to let go before the next connection happens. In 3G, by the way, it's make before break. So it's a much easier connection thing. So one way that they solved this is one base station now controls multiple radio sites. And that way, you have less breaks. You have less physical connection differences between the different base stations. And you need less base stations. And they're in less sites, in less locations, which means you probably there are less taxable events happening for you. And this can really help lower your rent. It lowers the equipment. There's less square footage at the site, and it has a lot of advantages. And now, what we're doing right now, and where we're moving to right now, is what is called Open RAN. I don't know, have you heard about Open RAN? Right? That's the next new thing, and it's a lot more difficult than it sounds, because the only thing that is, and here we're taking this to the next level. The nice people at Dish, I don't know if anybody is here, they have built their network based on this already. AT&T just signed an agreement with Ericsson, moving towards this. Verizon, T-Mobile are not far behind. Comcast and Charter, when they build their wireless network, are going to build it on this infrastructure. So this is the world in which we are going to live. The question is exactly when, because the future is here, it's just unevenly distributed, right? And so some of it live here already. And what you see here is like the full disaggregation of the value chain, where in the previous model, it was still the same vendor had the equipment and the hardware together, just like fewer boxes. Here you have standardized general purpose hardware, also known as a PC, right? x86 box, with a couple of fancy additions, controlling one or multiple radios, and then connect further out to a CU, a compute unit, further out, usually one within about 100 miles, and it's dictated here by latency. Latency, which is time, basically, time and distance, that is needed here. And then it goes virtualized out. The thing is that previously, the equipment was owned by the carrier. Here, it might be owned by the carrier, it might be owned by somebody else. It might be owned by Amazon, in the case of Dish's network. For example, here on the Packet Cloud core, AT&T outsourced that, for example, to Microsoft. So now that 5G packet core is Microsoft's, and that has a lot of implications for you, because who owns what depends on who pays taxes, right? And so this is where the changes are rapidly coming in how these networks are being designed. The idea is that it becomes more flexible. Now, when they say Open RAN, the only thing open here is the interfaces between the two. And the idea is that if you don't like, in the current world, if you don't like a vendor, you have to physically rip out that box. You have to physically put in a new box. It is expensive. It is painful. Many years ago, and getting a new vendor in is extremely hard. When was that? In the mid-aughts, AT&T, or Singular at the time, tried to get a new vendor in. Siemens, that provided mobile networks in Europe, and they gave them a third of the US. That went horribly wrong. And it was a massive, massive effort to first to move the Siemens gear in, right? Try it, work it, and then pull it back out. And the reason why Singular was behind in the deployment of 3G was that this network decision that didn't work out. Where we are now, or where we will be with Open RAN, is that you can pick a different software provider that runs on that standardized core. The idea is that it will be working plug and play, like you're changing out Word for. There used to be many software platforms, right? And in a way, what you're seeing a little bit here is like Open Office or other solutions, and that you basically switch out the software and that it will work flawlessly. The reality right now, at the beginning of this, it does not work flawlessly. So right now, even if you do Open RAN, the reality is, like Dish learned that the hard way. They had, like in some markets, the software from Avenir, equipment from Fujitsu, Altio Star they had in there. And the reason why there were delays was that the stuff didn't work together. Then they made a deal with Samsung, where Samsung provides that whole stack again, and that works a lot better. But the vision is still that you can change out the software independently from the hardware. Will it happen? Eventually, but we don't know when and how. But the reason why, for example, AT&T went to Ericsson, which was a laggard in Open RAN, and gave them, what, $14 billion, is to make this work. And to provide then the opportunity to use other providers. Some of the things with the equipment, it's sometimes not fast enough, so you have to put like equipment in and software and all of that stuff. By the way, any questions on this, or did it just go woo? Because it's like pretty network engineering centric things, and
Roger,
you.
I got a question.
Yes, sir.
Roger, I got a question for you. When you talk about the engineering and the open network, I mean, it seems like there's always been, you talked about competition dwindling because the carriers squeeze the vendors lose margin, there's consolidation, there's always been this issue. You look at the stock prices of Nokia and Ericsson, some of the other things. How do you reconcile R&D in the cutting edge versus the carrier, and who's going to take that slice? Is it just going to be a new software contract that Ericsson's going to maintain, and it's really not open. It's just going to be a new platform on the software front instead of the hardware front. And maybe you can talk a little bit to that point.
So, right, it's history all over again to a certain extent. But there are technological breakpoints, right? So historically, because of the massive investments that are required to be both an expert in hardware and software, it was like inevitably dwindling down to fewer and fewer vendors. Yet then the Chinese come in with government money disrupting things. Here, the hope is to open it up to more vendors. Because when you take the software engineering out, essentially, as a software engineer, your barrier of entry is so much lower than it is from an integrated software and hardware provider. And so the hope is that more and more software is coming in. So you had, there's, for example, a provider called Mavenir out of Dallas. And they are cloud-centric, packet, all of that. And they are actually making good progress. The area where they have the biggest problem is building radios, because they need multiple year lead times. And so I think, I think it will work for some time. But what we've seen also on the network, on the core network side, is that you have innovative vendors coming in, and then the Ciscos, the HPs of this world are throwing a lot of money at them, and they buy them, right? Should it be better than before? Yes, absolutely. So the hope is that this becomes more like the traditional consumer hardware, where you have a lot more innovation because of or the services, because you take the massive investment in hardware out. So that's the hope. We'll see how that works out, right? Because we've seen in a lot of core network stuff that just the big guys deliberately, the carrier bought services and software from the little guy just to see them taken out by the big guys. Now that's shame on you for not putting a change of control clause in that contract, but it should look better.
Thank you.
Yeah.
Any other questions at this point?
Yeah.
I have a question before you move on.
Yes.
So as I understand it now, some of the key control will be taken away from the carrier, and now it's going to live on the cloud with Microsoft or Google or somebody.
Yep.
So that if Microsoft or Google goes down, so does my cell phone service?
In the unlikely event,
Good to know.
yes.
Okay.
So if you're running the loads on Elastic Cloud, but the idea is that because they have so much more compute power, that you won't go down. So the number of instances where Amazon went down is well publicized, but far and few in between. So the expected downtime is probably similar to what we've seen from the carriers. The carriers have not been flawless either. And it's typically when there's in a steady state, networks don't go down. It's when they do software upgrades that everything goes down.
Okay. Thank you.
You're welcome.
Any others? Are we going? No.
All right. So it is important for you to know, because your whole world that you're living in on the network side will change, right? So we talked about fixed wireless, and how fast can this get, right? Um, and where do we go? And we have a conversation later on with around the bead money. I think you will have a conversation. One of the things to keep in mind, the bead money is what, $42 billion? That's a lot of money. But think of it this way. A aerial mile of fiber costs $30,000. A trenched mile costs $100,000. So that is very reasonable if you have population density. If you're connecting somebody 5 miles out and you have to do a mile of fiber, say in that dark area here on top in the plains, where it gets really cold in winter, and you have the danger of fiber milking and going bad, you need to trench it. And so I'm not sure we will ever get a return on a $500,000 trench going out to a farm out there. Still, that person should have broadband connectivity. And here, and one way to get these people that are hard to reach is through wireless means. I'm using here Verizon's 5G spectrum as an example. T-Mobile has similar amounts of spectrum in 2.5 C-band and 3.45. AT&T has a robust network or spectrum available that they haven't actually tapped into. So what we're seeing here on the left, and I could have put somebody else up, is how much spectrum depth they have. Then the way to read this is like the dark blue, the darkest gray is 240 megahertz. 100 megahertz can give you up to 2.4 gigabits of speed. So 200 megahertz or 240 at the max gives you about theoretical speeds of 5 gigabits that they can share. And especially in rural America, there are not a lot of people to share with. If they put the channel cards in, this will run. And the other thing is that when you look at the build out, how all of the wireless carriers currently are building out. They're building out on what's called the AWS grid. I don't know if you're familiar with that term. So they're cell sites, and they're designed in a spacing that it works with AWS spectrum. And if you have lower spectrum that's in lower frequency, they power down the signal so that it doesn't go further out and interfere with somebody else. And if it's higher up, they power it up to the legal maximums. And one of the big surprises was that with massive MIMO, meaning you can have that, like these, instead of having one antenna, you have like 64, 128 antennas, 32 antennas. That's like when it says like 32 by 32, like 32T times 32R. That means there are 32 transmitter and 32 receivers, right? That they can do that, and so you can use that same spectrum more often, and you can focus on more people, because then every one of these little antennas can be aimed at you, and each of you gets one beam separately. And that really helped with throughput and with interference and all of that. And so come to, like when we look at these dark areas, and for example, Verizon deliberately bought it in these rural areas to provide FWA in these areas where where they have a cost advantage because they have near where are we now? We are now at about 98, 99% of population coverage. So there is a wireless signal where there are people living. And they're going to roll this out. The question is who will win, right? And when we look at, all right, there's a clear difference from consumer preferences right now. So one of the other things that we do is we run the fastest, largest, most flexible customer insight service available, bar none. We interview every single week 4,000 wireless customers, 4,000 home internet customers, 500 businesses, and ask them a lot of questions that are the same and a lot of questions that are new every single week. And some of you are our subscribers. When your leadership has a questions, they give me an answer Thursday night. By Monday night, they get a Tableau dashboard. Tuesday night, they get a presentation. Wednesday, we present it, and Thursday, we start again, 52 weeks a year. So what you see here is, this is based on almost 161,000 responses over the last year on how happy are customers with their home broadband service. And there's a clear, let's see, this gives me a red point. There's a clear hierarchy between fixed wireless, fiber, cable, DSL. And here we measure this in 16 different dimensions. Customers are generally, and by the way, do you know Net Promoter Score? Somebody who doesn't, Net Promoter Score, and how it works? For the ones who don't know, you probably get like these questions on a scale from 0 to 10. How likely are you to recommend this to your friends and family? What they do then is, and what we do is, we take the percentage of people who say 9 and 10, because those are the people who will go around and say how wonderful the service is, and subtract from it the percentage of people that say 0 to 6, because those are the people who will say this really sucks. The 7s and 8s don't say anything. And so this is the percentage above and below. And you can see for like here and we then go in dimensions. On the technical side, which is more on the left, everybody besides the DSL providers does a pretty good job because the number is above 0. And you want to have a positive percentage, have there. The people on fixed wireless are like straight out ecstatic, right? And we can talk about why. And so fixed wireless, with the limited spectrum that has already been allocated, is delighting customers all across the board, even customer service and the in-store experience, they figured out how to do that. Because everybody else hates going to the store. I'm not sure how you feel about your provider, but generally it's like near root canal levels, right? And this is the case, even though that fixed wireless is slower than fiber, right? It has higher latency, and it still delights customers more. A lot of it has to do value for price, because, you know, depending on when you bought this, it's somewhere between $25 and $50. But it delights customers all around. Fiber, on a technical side, beats cable. We will see how this changes when cable switches from DOCSIS 3.1 to 4.0. And in the labs, it looks good. We'll see how it works when it conflicts with the real world. And DSL is just on the way out. People are miserable there. By the way, what's really interesting when you look at, sometimes we have two, like for example, Optimum, which is LTs. They have both a fiber and a cable network, and the fiber network makes people a lot happier. And the same is true with Frontier, that has DSL and fiber. I'm not sure if I'm showing that slide, but we have one slide that shows like, let's see, no. We have one slide that shows like everything gets better by speed. So let me go back. So if I look at all of these things, all of these metrics, and it doesn't matter, there's differentiation between like download speeds and streaming satisfaction. But one of the fascinating things about that chart with everything gets better with speed is as customers go up in speed here, Net Promoter Score for everything goes up. They're even happier with their technical support and their billing support over the phone. If you have a gigabit connection, you are happier with haggling with your customer service person over pricing than if you have DSL. Really interesting data that shows you how speed is coloring the entire customer experience and interaction. So here we are looking at where do these people come from. And the key takeaway is FWA is a threat to everybody. The conventional wisdom is, yes, these are refugees for who DSL is not fast enough, or who think that cable customer service touched them in the wrong place. And they're like, I finally have a way out, right? Right? And they're like, yes, freedom, right? I can go, right? It's with everything. Even fiber customers are picking a slower product, right? And with satellite too, we even see, and I'll show you data, a breakout on Starlink with this other stuff. But it's a threat to everybody. And so just because you have fiber or you have then faster whatever, doesn't make you immune from FWA. Because it's a flaw, it's a pretty good experience, because one thing where we talk about that these numbers are a little bit boosted by survivorship bias is the installation process is so easy. You go in the store, you pick up the box, right? You take it home, it either works, and you know that within like 10 minutes, or it doesn't. And if it doesn't, you take it to the store 3 days later, and you're rid of it. And we can't find the people that are unhappy in the 3 days, or we can't find that many people that are unhappy in the 3 days. Whereas if you committed to a wired connection and they drilled a hole in the wall and you signed a contract, it's not that easy to get out, right? And then I'm like, oh, I have to go this. Because like I have some of my people, they run this in parallel, right? One of my colleagues, anybody here from Cox? Nothing against Cox. But like, one of my colleagues in San Diego, every afternoon at 2:43, we can set the clock. That network is going down for about 3 to 5 minutes. Every day, right? It's like insane. And so he tried the right FWA service from him and ran it in parallel. And then like, okay, I'll use this, right? And so that is a big danger. All right. Now let's go to that, that big hope in the sky, LEOs, or I've worked on this. One of the first projects when I got into telecom in the 1990s was about satellite internet communications. And it was the hottest thing, and it still is the hottest thing, and one of these days it will become true. But we have to look at it this year in two flavors. One is as a mobile network satellite augmentation, and the other one is as a home internet solution, right? And so all of the wireless carriers have now made an announcement, and even Apple has, that they will partner with somebody to fill all the dead spots in this country. AT&T picked a company called AST, Mobile Space, T-Mobile made an announcement with Starlink. Verizon said they will use Amazon's Kuiper. If you have an Apple 1415, that SOS satellite comes with a connection with Globalstar's aging satellites, and that's why it takes 15 minutes for your signal to go through. Because one of the things that you can't escape is physics. Because these antennas, these satellites are up about around 400 kilometers, 300 miles in the sky. And the further a signal is away, the more it attenuates, means it gets weaker. That means you need an antenna. There's no matter how much software engineering and magic and whatever you do, you need an antenna. And customers and consumers have been very adamant that they want their phone, not with a little stub or long stub or whatever stub on their phone, but they want to use this with their normal phone. So like the Iridium guys, they were the first ones. They're being kept alive by the DoD because the DoD and special forces have like the phones with like this long of an antenna, and if you're in the middle of nowhere trying to blow something up and the government pays you a check, you accept that. If you're a consumer, you don't. So that's why so they all have to launch satellites that come with really big antennas, and that means these satellites are heavier. That means these satellites have more drag. That means these satellites need more power. That means these satellites will fall to the Earth more quickly. And so the lifespan of these satellites will be shorter, which means there's a faster replacement cycle, which also means it's a lot more expensive because having these satellites in the sky costs billions and billions of dollars. When we look at here the application for cell phones, because the magic here is that it works on the same frequencies that are in your phones, and that's why you don't, and not a bigger antenna. That means there's this nasty thing by which we talked about before, interference, right? And so if there is no interference, meaning if there is no cell site around, this works actually reasonably well. And if you're the only person there, so if you're in the middle of Idaho or Montana, there is a fire and you jumped in with 23 of your colleagues with a parachute to extinguish this fire, this will work pretty well already now. They showed it, that they can document to their control thing, Here's a video of that fire in the middle of nowhere. It works because they're the only people there. There's no interference, no nothing. And so with AT&T saying they will use this for first responders works really, really well because there are few people far in remote places. The closer you go to people and the more cell sites there are, the more interference you will get. And so you hope to use this as a way to close cell site holds in Manhattan is 0. Because the cell site spacing in Manhattan is 100 yards and the interference goes like through the roof. So that's like, and this will help, there are enough people who are now climbing down Mount whatever, while being really out of shape, and they make it barely up, and then they make their call on the top of the mountain to their friends, showing like, look at where I made it, and the second call is to mountain rescue of, where's the helicopter to get me down? You're laughing, that's really what happens. This will be an ideal solution for that. It will be even better and more. And you will see about the unintended consequences, right? And so, pick me up, it's a new version of Scotty Pick Me Up, right? Where's the Enterprise? I'm looking forward to like all the reports and then like a helicopter named Enterprise showing up. That would be funny. The spoofs make themselves. But anyway, so that's like the great hope for a satellite service for mobility. It will work where nobody is, right? And where nobody lives. Now, we talked about, and you asked the question about how does this work for broadband. So the good news is, this is the data over, there are relatively few people around. So this is the data on almost 88,000 respondents, which the statisticians among you will be very excited about to see sample sizes like that. Starlink delights people. It delights them more than fixed wireless. This is like over the entire almost 2-year time frame, and this includes the time when fixed wireless didn't work well. We could watch in live week after week of how Verizon and T-Mobile fixed their routers, and they fixed their network, and they fixed their sales process, and we saw it all in our NPS numbers. But Starlink works very well from day one. Traditional satellite from Viasat and Hughes, -2, not that prickly, right? It's slow, it has low latency. The speed is less of a problem, the latency is really the killer that gets you there. I have a friend who plays online games literally out of the middle of Australia. His latency is 530 milliseconds. It's insane, right? That's half a second latency. I see him dead before he sees himself dead. But yeah, so the LEOs, the Starlink service, will be especially a solution for the even fewer people. It will be a fantastic solution for 1% and 2% of the people that are outside the wireless solution. Now, with Starlink, once these satellites are up, at least for the first time, it's a sunk cost. So they will try to monetize this left and right, and will give it a running battle. The question is what happens when all these satellites come down in 3, 5, 7 years? Can they keep that constant, really expensive replacement of satellites in place? And that's why Starlink and others are trying to also get money from the wireless carriers to subsidize it. And satellite business Starlink and others is inherently a global solution. I don't think, the good thing for them is the US, we have a lot of disposable money. But the networks, especially with FWA and fiber now coming, there are not that many people around where this is the case. Whereas if you pick the country around the world with a relatively inferior technology, you typically have less money, but that's where this solution really shines. Because how many people, it's $120 a month with Starlink. The CPE costs $600. The speeds right now are advertised up to 100. They should get faster. That. Any questions? Because I like talk like a waterfall.
Okay. Wait. Yeah.
Let's have I go first.
Yeah, you can just hold it.
I'm glad. I hate talking with an empty room.
Roger, is it just the interference that's holding back LEO service from kind of taking
To
over
cell
the world?
phones?
Yeah.
And capacity, right? It's really hard and expensive to put capacity several hundred miles up, and you need rockets and all of that stuff, whereas a cell site, you can take a truck, move it there, and it's a lot cheaper from that perspective. It's both the capital investment and then the interference,
Okay.
right? So it's really about marrying the right technology to the right use case with the right investment profile. I mentioned trenching a mile is $100,000. Sending up one of those rockets is still like $100 million, if not more. And what can they send up? 20 satellites, and they're the small ones. I think with the brand, they need like Falcon Heavy. I don't know how expensive Falcon Heavy is, but I can't imagine cheap. And they can put like what, 5 or 7 up of the new ones with these massive antennas and all of that. It all starts heavily into money. That's in the end what the problem is.
Okay, so yeah, it sounds like there's a capital investment issue, and shooting rockets into space is not getting cheaper.
It's not getting cheaper. Also with Starlink, you have the problem that you need clear sight to the sky. Initially, like if you had like one tree at the horizon, it said like, no, can't connect. They're working through these issues, but it's also like, how much line of sight do you have to the sky? How much, right? If you're living in more rural parts, your night sky is not obstructed. If you live in a city, how much time do you need line of sight to this thing in the sky as it moves by with 20,000 miles an hour? And so there either needs to be a ton of these, that it's like always in this, like say you have only like 10 degrees, right? This, right? There needs to be a satellite all the time there. And so that makes a really high demand on the number of satellites that they can put up.
Got it. Okay, yeah, then I mean, it certainly sounds like you're really looking at a complementary service.
Yes.
You know, where the further out you go from fiber to fixed wireless to satellite service.
Correct.
And that's how you get to 100%.
And that's how you get to 100%. And even like if you're Ted Kaczynski and your hut is under a lot of trees, you might have used your bombs to take off. Well, then he hated technology, but you still need line of sight to the sky, right? Or if you live on like one mountainside, and the cliff goes straight up, you have only half of the night sky, and that interferes then again with that. All right, and that was me.
Okay. Any more questions?
Yeah. Oh, the cost has come down dramatically, but it's still not cheap.
No, not cheap, but it's.
Yeah,
Yes, sir.
Roger, you talked about it a little bit earlier, and I know this isn't maybe your topic of the day, maybe covered later, but BEAD money, is satellite part of that, or is it not part of it? Do you know? Or maybe it'll be covered later.
The FCC decided, well, Elon Musk applied for it, wanted to have it. There's a proceeding. The FCC said no. They're going back and forth. So right now, legally speaking, it's not part of it because the argument is that it should incentivize new investment. And since he has already satellites up and made the decisions, it's not stimulating more, but it's just making his business case easier. And so that's the current rationale. We'll see if a judge, with who the judge will agree many, many years later. But right now, satellite is not part of it. So it's wireless and terrestrial, or it's terrestrial technologies, fixed or mobile, that's eligible. Yes.
We do have a question. I'm going to go ahead.
Woohoo. They live. There's life on Zoom. Yeah, unmute the person, please.
Anthony? You want to unmute yourself and ask your question?
Yeah, you can go ahead with your question, Anthony.
Are you there, Anthony?
Can you hear me? Yes.
Yay!
Will we be seeing an increased need for modern Earth stations being installed across the U.S.?
We have not yet. Is it possible? Yes. But I haven't seen anything in filings about an increase in new stations, ground stations, terrestrial stations for that. Okay. Well.
Hold on, Anthony. Okay, now go ahead.
Yes, sir.
Nancy, did you want to say something else?
Anthony, do you have anything else to add?
Perspective, I know the old Earth stations have become obsolete and dinosaurs, and you know we've moved them basically from a network to a company like AT&T. And I know from the DirecTV perspective, we're actually reducing the number of our Earth stations. So that's where I was trying to understand, you know, if we move back towards that satellite model, will this become a new need again? Because they have to find the proper longitudes and latitudes.
Yeah.
You were saying in the clear skies of, you know, the northern stars.
Yeah, we haven't seen anything yet. And who knows? Elon Musk magic, I don't know. Oh, yeah. Awesome. Well, if you have any questions, feel free to reach out.
I still have a question myself.
Oh, good.
I actually have two questions. One on the fixed wireless, for the Verizon and T-Mobile. What are the line of sight issues there? Are there any line of sight
No
requirements
line
at
of
all?
sight issues.
Absolutely.
Because they're building it on the AWS grid. It all bends around and there are no line of sight issues. This is not like 24 gigs or higher. This is all sub-6 bendy electronic waves.
Good. Follow-up question. You've touched on this, but see if this summary makes sense to you. of US households, maybe 1 or 2%, it's gonna be satellite. They might not even have electric service or telephone service or DSL, so we'll serve them that way, up to 100 megabits per second for now, maybe more later. Then there's, say, maybe 10% of the population, or 8% of the population, up to the next 8% or so, that don't get passed by cable. They probably have telephone service and some cruddy DSL. They're just an obvious match for fixed wireless today, and that's probably why they're so darn delighted.
Will be more.
Pardon me?
It will be more. If the earnings calls, like Verizon had an earnings call yesterday, T-Mobile this afternoon, they both will say that they will meet, and either they said or they will say that they will meet and exceed their goals, which for Verizon was 5 million, and they're planning for 10 million FWA customers. T-Mobile is at 7 million. They will also exceed their goal. So FWA looks much more like 15, 20 million households. There might be people who have both.
What I'll get to next is that for that 10% that don't have cable service, aren't passed by cable.
Yeah.
I mean, it's easy for fixed wireless. And then there's another percentage of folks that are served by traditional carriers, cable or telco, and their fixed wireless is now a competitor, and up to at least very high speeds. And then the question is, going forward, will they keep up in terms of bandwidth? Then when it comes to the B type of money, the question is whether it makes sense to build out fiber to them or to go fixed wireless alone. And that's kind of where we stand.
Well, some will build out even though it doesn't make sense.
Okay.
Right? That's built into the system. Right? It will happen, right? And so you will have again, and the government goes for also technology competition, so that consumers have choice of multiple providers and ideally multiple technologies, which from an accounting perspective makes no sense whatsoever. But we want this from a public policy perspective so that people have choice and that there's a corrective measure. And yeah, you will have 80, 90% will have access to a fixed connection. Maybe cable, maybe fiber, 100% or probably 70, 80%, depends on where it makes sense, right? You will not have FWA everywhere because the FWA revenue per gig is like in the cents, and the FWA and the data revenue for mobile is in the dollars, and you prioritize over what gives you the highest yield. Okay. Awesome.
Well, thank you very much, Roger.
Thank you.